All right, so in lesson 4.6, that was talking about slope-intercept form, right? We graphed a line given its equation in slope-intercept form, which is y equals mx plus b. Remember, when we graph those, we graph the y-intercept first, and then we graph the slope. So we could graph from this form, slope-intercept form. You can also graph a line with its given equation in point-slope form, which is y minus y1 equals m multiplied by the quantity x minus x1. And the first thing you graph is you start by using the equation to identify a point on a line. So you graph that point on a line first. And then once you have graphed that point on the line, then you use the slope of the line to identify a second point. So from that point, that first point you graphed, then you graph the slope from that point and you get a second point. And then boom, you have 2 points and you can graph the line. So let's go ahead and look at this. So we have an equation right here. And what we're going to do, this equation is in point-slope form, and we're going to graph a line. So the first thing we need is a point. Now this is point-slope form, right? So we know this is y minus y1 equals m multiplied by the quantity x minus x1. So we need a point. We need an x1 and a y1, right? So our x1 is here. It's 3, right? This negative is actually a part of the formula, right? So we know that our x1 is actually going to be 3. It's going to be a positive 3. So whenever you see this negative 3, you just need to think about a number that's opposite of a negative, which is a positive, because this negative is a part of the formula, so that means our x1 is actually 3. So the point we're going to use, the x1 is 3, and then the same thing is true here. This negative is a part of the formula, so y1 is actually a positive 1. So that is our point. 3, 1 that we're going to use, and then our slope, so we do this first, and then from there we graph the slope being 2, which is a fraction, 2 over 1, which is our rise over our run. Perfect, let's graph it. So we're going to graph that point first, 3, 1, which is here, and from there we're going to graph the slope, up 2 over 1, up 2 over 1, and then the opposite, which would be down 2, 1, 2, and over 1 this way. Down 2 over 1, down 2 over 1. Perfect, time to connect the dots. All right, there we go. I need to grab, I think I didn't connect those very good. Okay, that's better. Perfect, and then put a line, an arrow on the end, and you have your line. Just ignore that, I accidentally made that little mark. You graph the point first, and then from that point you graph the slope for a second point, and then you can connect the dots. Perfect, let's go ahead and try another problem. All right, great. So here's our equation in point-slope form, right? Y minus y1 equals m multiplied by the quantity x minus x1. Okay, we need the point. So the point is x1, y1, and it's always going to be opposite. So if this is a positive, that means my x1 is going to be negative. And then my y1 is going to be opposite of negative 4, which is going to be a positive 4. So that's my point. That's what I graph first, and then the second thing I'm going to graph is that slope, which is right here, 3/4. So let's do it. So negative 2, up 4, there's my point, and from this point I graph the slope. So up 3, 1, 2, 3, over 4, 1, 2, 3, 4. And there we have it, my point and my slope, and now I can graph my line, which is right there. Awesome. Okay, let's look at the next example here. Okay, so this is in point-slope form as well, right? We have y minus y1 equals m multiplied by the quantity x minus x1. Okay, so our point is going to be x1, y1, so it's going to be opposite. This is negative 4, our point's going to be 4, and then opposite of positive 3 is going to be negative 3. That's our point. And then our slope, we do that first, and then our slope is actually equal to 0. So let's go ahead and graph that point first. 4, negative 3, so here's 4, negative 3, negative 1, 2, 3 would be right here. And then the slope is equal to 0. Now remember, this is the rise over the run. So if the rise is 0, right, That means it's not rising. Remember, whenever the slope is 0, that means that you're dealing with a horizontal line. So we have a horizontal line that's actually going through this point right here. So that is how you graph that one. Perfect. Okay, now it's time for you to check it out. So I want you to try to graph this using out of the point slope form. All right, here's my friend the pause dragon. Remind you to pause your device. Go ahead and work the problem out. When you get done, press play and we'll talk about it together. All right, see you in a bit. Okay, let's see how you did. I'm gonna go, this is in point slope form, so I'm gonna write that point slope form down. Okay, so first I have to identify my point, right? It's the x1, so it's -2. It's opposite of that, so my point's going to be 2, and opposite of the +2 is -2. That's my point. I graph that first, and after that I graph the slope, which right here is just a negative, and this means it's a -1. So the slope is equal to -1/1. So I'm just going to graph that point first. 2, -2 is here. And then from there, I'm going to graph the slope. So down 1/1, and then I can just keep going. Down 1/1, down 1/1. And then I can do the opposite. I can go up 1 over this way, up 1 over this way. Oh, look at that. It actually looks like it goes through the origin, which would mean it would be a direct variation. How exciting. Man, that does not look like a y equals kx, right? But I bet you if we solve it, it would end up being y equals kx because it goes through the origin. Okay, now I'm kind of curious. I'm going to solve it really quick just because I want to see. Okay, so this is the equation, right? Y plus 2 equals -x minus 2. I know that this is a direct variation. So first, to solve this for y, I have to distribute this at negative to both things. Y plus 2, negative times x is -x. Negative times a negative is a +2. And then y, for a direct variation, you got to get y by itself. So I'm going to subtract 2 to both sides. And I end up, that cancels, y equals, those cancel, -x, boom, there's my formula, y equals kx, where k is equal to -1, which is the same thing as a slope, right? So it all makes sense, it all ties together. This is a direct variation, it goes through the origin. It's a special one. You didn't have to do all that, I just did that because, I don't know, I felt like it. All right, on to the next example. Check it out, example 2b, here we go. We're gonna graph the line using point slope form. Where's my friend? Here's my friend the pause dragon. Remind you to pause your device. Go ahead and work the problem out. When you get done, press play and we'll talk about it. All right, see you in a bit. Okay, let's see how you did. This is in point slope form. I'm going to go ahead and write that underneath so then I know what everything is. Okay, I got to find that point. It's going to be opposite, right? So if this is -1, my point's going to be a +1. If this is +3, my point's going to be a -3. So I graph that first, and then I graph the slope, which ends up being -2/1. All right, perfect. So I graph the point first, 1, -3, right there. And then my slope is -2. Did I graph the point right? 1. Yeah, that's +1 and -3. Oh, okay. So I think what I'm going to have to do, because if I go down 2/1, I'm going to run out of space on the graph. So I'm actually going to have to look at this slope. Instead of it looking like this, I'm going to look at it like this, because it means the same thing, right? You could just put that negative in one spot. So from here, I'm going to go up to 1, 2, and over -1, which would be this way. 1, 2. So that's kind of a trick you can do if you run out of graph paper like I just did. And then you can still graph the line. Okay, and there we have it. All right, so if you got that right, awesome job. If not, go ahead and fix your graph, and yeah, I'll see you in a little bit for example 3.